So as it says, I'm going to be talking about object-oriented data science for production. And I'm not going to be making, I don't think, a very controversial statement. But basically, I'm going to talk about the fact that most data science examples online are prototyping. It's solve the problem. There isn't as much discussion of how do you take something from a prototype that you hack together in Julia or Jupyter and get that all the way to production. And in particular, I'm going to be talking about how using an object-oriented approach can be really helpful when you transition from your prototyping code to your production. And I'll give some examples of how that's done and talk about what we do at Empower the User and using that. So just making sure we're all on the same page. I'm sure this is pretty familiar for all of you, but generally speaking, there's prototyping or hacking, and then there's production. Right? And so when you're prototyping, you use Jupyter or Julia because you want to be in your code, you want to have it all open in front of you like you're working on a car engine and the parts are all over the place. Your priority is that you can see what the code is doing and you can edit it as fast as you can, right? And the question is just, will this work at all? But when you move to production, you tend to pack away a lot of the code. You want the code to run smoothly, you want it to be scalable, you want it to be fast. Your priority is no longer that it's, editable immediately and quickly by you. And so, because those things have different needs, generally speaking, different programming approaches work for them. And so, I didn't mean to say functional versus object-oriented. It should be procedural versus object-oriented, because functional programming is its own specific approach that we're not doing, so ignore that. But the big thing that I'm going to be talking about is that the most helpful thing for data scientists, I think, with an object-oriented approach is that it tracks state. And what I mean by that is, if you've done any data science at all, you probably are familiar with the experience of having 5 different variables that are all called some version of data underscore raw, pilot, cleaned, with 2 variables, normalized. You basically have all these different forms of your data that are floating around, and you're using different forms of it for different models and different situations. And when you're prototyping, that's fine. You can use your own brain to keep track of what's going on. But when you move into production, you want your code to be something that not only you can use, but your team can use, that you can go in and edit, that'll make sense years later. Having a structure, like an object, that will keep track of state, that will essentially know which form of the data you have there and which form you need to use for which model, makes a big difference. And so that's, I think, the big draw of using an object-oriented approach, is that it will help you keep track of all the different ways that you manipulate your data. And so because I didn't want to make an assumption about everyone's familiarity with object-oriented programming, I will be talking a bit about its basics. If you already totally know that, check your email. Sorry about that. So classes are the fundamental unit of object-oriented programming. So a class is essentially a predetermined structure that you set up that combines attributes, which outside of OOP we call variables, and methods, which are functions. And it essentially hard codes the links between different attributes and the ways that those attributes interact with methods. So you can say specifically, only this particular form of the data works with this function. And I don't have to remember that I need, data frame underscore, normalized underscore transformed goes with this function. I'm going to associate that data with that method. And so whenever I call that method, it's going to automatically know that I need that shape of data. Which sounds silly until you change a small thing in your code and suddenly it won't run anymore because you've forgotten that you put 2 underscores under one of your variable names, and it's a whole situation. Maybe it's just me who does this, but yes. So, for example, if you make a class called dog, it might have attributes like breed, color, and weight. Then you'll have methods that you can use to act on the dog, like bark, eat, breed, or set weight. And I'll talk about why the set weight has underscores in a moment. When you take that structure, that class, and you fill it with information, that's called making an instance of the class. So you might declare an instance of class dog, where the breed is husky, the color is white, the weight is 8, and call it my pet. And so what you've done is you've said, well, I have this structure of how this information needs to relate to itself, and I filled in the structure with these particular details. And now I can work with that structure in specific ways. And so, again, I expect that for many of you this is familiar territory, but just to make sure we're all on the same page, these are the principles of object-oriented programming. There is some debate about whether there are 4 or 5 or 3. I have gone with 4, but I'm not making any kind of canonical statement here. For data scientists, in my opinion, the most important aspects of object-oriented programming are encapsulation and abstraction. So I'm going to spend most of my time talking about those. So encapsulation is the ability to take information that you have and essentially restrict who or what methods can work with that information. So for example, you have a data frame and you've shaped it the way you shaped it and you don't want it to change. And normally, especially this can be an issue if you're working in a shared code base, someone else might go in and write need to change that data frame, and they might override it. And now all of a sudden your code doesn't work because that data frame has a new feature in it or has been transformed. And it can create real problems. Well, if you're using an object-oriented approach, you can essentially set things so that your attributes can't be changed without someone going in to do the class code. And so the example here, I hope will make clear. So we've declared our pet, and their weight is 8. Let's see if I've got a laser. Yes. And so I, being a naive person, go, oh, well, I know that the attribute is .weight, so I'm going to set it to 9 because I want my pet to get a little bit fatter. But when you check, the attribute didn't actually change. That's because I've restricted it so that the only way you can change it is by calling the myPetEat function, which will then change the myPetWeight variable. I can't just go in and change it myself. I have to use these specifically defined methods for the class to cause the attributes to change. Now, not all class attributes have to be restricted in that way. You can have class attributes that you can just set, but best practice is to essentially say, no, you can't talk to the talent. You have to go through the agent. You can't mess with the variables directly. You have to go through these methods that I've defined that allow you to manipulate the variables in ways that I can predict so that I know you're not going to break my stuff. So that can be really, really handy because it means no one's going to be overriding your variables by accident. You're not going to be overriding your variables by accident. And you always know what data you're feeding into your functions. You know exactly what shape it is because you're the one who controls that entire situation. And you may say, well, I'm in control of my procedural prototyping hacking code too. It's like, well, yes, you're in control, but with object-oriented programming, you're in control and you have a structure where you know and can predict and understand exactly what's happening. You know all the states that your data and your class can be in. Whereas if you're just a human hacking together some linear code, your variables can be in whatever state you as a person feel like putting them in that day, which means you as a person have to remember what you did the next day. So the thing that I'm learning as I use object-oriented approaches for production more and more is that it essentially replaces the need for me as a human to do a lot of the remembering and structural work in my head. Instead, it puts that remembering and structural work clearly in the program, in code, which is really good when I come back to something that I haven't touched in 6 months. So that's encapsulation. Then we also have abstraction. So abstraction is essentially the ability to say that some aspects of your code don't need to be visible to the end user. It makes your code more user-friendly. So you can have methods like, for example, setWeight. There's a double underscore there, which in Python means that that is a method that can only be used inside the class. In other words, a human can't go and call, oh, I want to set my pet's weight to 10, so I'm going to use the setWeight function. That doesn't work. What in fact happens is that the eat function calls setWeight inside itself, and that causes the weight to increase. And the reason why this is nice is because you can have a lot of really complex functions, really technical functions, and you can say, well, I don't want my end user, who might be a programmer on another team who needs to make my program work with the interface, to have to look at all this stuff, because it's all internal, they don't need to know it. You can say, look, these are the methods that you need to know. These are the things that correspond to the interface. You worry about those, and I'll worry about everything else. This is also handy because it means that if you've got these internal methods and you want to change your code, you have a really nice distinction between the external other people facing methods, which you want to not have change. They should not change, right? They should always be giving the same expected output in the same expected format, because that's what the people writing the interface that your ML program works with are expecting. And then you also have these internal methods that you're working with, and you can change those however you want, as long as they end up giving the external facing method the outputs that they expect. And so that can be really handy, because it means if you decide you're going to upgrade your code and you've changed everything about the innards, you've got a nice thing to remind you, this is the external outer facing part. I shouldn't change that, because that will break the entire product team's thing, and then they'll be really mad at me. So abstraction is a nice way of sort of keeping the tidy, nice stuff, tidy and nice and consistent, and then letting you mess with the guts, on your own. Two other principles that I don't use as much with object-oriented approaches in data science, but others may, are inheritance. You can declare a class like dog, and then decide that you want to make another class that has all the different attributes and abilities of dog, but also has some other things. So you might want to declare a class that is, teacup dogs. And it has all the different things, breed, color, weight, but it also has special functions like, break a leg, because teacup dogs are terrible and fragile. New different things. And so instead of having to write a whole new class all over again, you can say, I didn't want this class, I want to use all the stuff from this previous class, and then I'll change a little bit. It's like a parent. It's got all the stuff that the parent class comes from, and then as a child, it has its own things as well. And so that can be very handy. There's also polymorphism, where you can declare different children of a class, and you can overwrite, excuse me, like the previous speaker, I'm a bit sick. You can overwrite some of the methods. So you can have a method like speak, for example, and your dog class says woof, your duck class says quack, your cat class says meow. You're calling the same method, speak, right? The people working with your interface don't need to know that in the guts, these different classes are using different internal methods. And so, especially with encapsulation and abstraction, these things come in really handy again, because they're carrying your structure with you. Instead of your structure being in your brain, your structure's on the page. And that is extremely handy. But a lot of people think about object-oriented programming. If you haven't done it before, it can seem kind of really complicated. You're like, well, my stuff works already. Why do I need to write all this, stuff? Why do I need to worry about which of my methods are accessible to other people and which are private? Why do I have to care about that stuff? But it's really not that scary. Because if you're a data scientist and you're working in Python, you're already working with classes anyway. Aside from just the fundamental, classes that get used in data types, that kind of thing. Panda data frames are classes. So if you've made yourself a data frame, that you've made an instance of class data frame. It has attributes like shape, that's just a trait that it has. And it has methods, transform, mean, describe, all these things that you use, right? That's a class. And you may have noticed, I hope no one's ever done this, but they probably have. I have. You might mindlessly one day decide you want to change the shape variable of your data frame. Why you would do this, I don't know, but sometimes it's 3 a.m. and we're tired. So you may have decided to assign something new to your data frame shape and then realized it didn't stick, right? Because this is not a variable, then not an attribute that you can mess with without using, without getting into the guts of the data frame program. So it's really nice in that way. You cannot mess yourself up by having a shape attribute for your data frame that doesn't actually reflect the shape of your actual data frame. And so that's a really, really handy part of encapsulation. And also, of course, if you use scikit-learn, which, again, most data scientists in Python do. If you aren't using scikit-learn and you're a data scientist, I'd like to talk to you. I'm really curious what you're doing. Again, their models are classes, right? You sit down and you declare an instance of, class SVM. You want your vector machine classifier. You declare the class, the instance of the class, and then you use the methods like predict and fit and etc. And everyone likes scikit-learn because it allows you to use really powerful libraries, really powerful math without having to know much about its guts, right? And that's sort of the beauty of class-based programming, or of object-oriented programming, is that you can do that. And you can write really elegant, clean code, which again is not a priority when you're hacking something together. In fact, I find using scikit-learn kind of frustrating sometimes when I'm prototyping because I want to know something very specific about, how is this attribute, like setting gamma to 5, where is that in the code? And I have to actually go down into the base code of scikit-learn and mess around. But when I'm an end user, when I have production code, I don't want to do that. I just want to say, I want this model, I know what output it's going to give me, and I don't really care how it's doing it. And so that is sort of where you want to get to with your production code, is when people can use it and say, I know what this is going to give me, and I don't have to care about how it's doing it. And that's when you want to shift. So you've worked with classes before, if you've done this at all, so hopefully it is not too scary. I'm going to skip this because it's lots of text and annoying and go directly to the example, which is more fun. This is super, super basic, but hopefully still useful. So what I've got on the left is a procedural way of doing for a situation where you have raw data, you clean it, and then you want to fit two different models, each of which requires a different form of your data. And so with the procedural, both of these methods are going to share these functions that I've not told you what's in them because it doesn't matter. Procedural, you basically load your raw data, you call your clean function, you transform the data into forms A and B, and then you fit models A and B. And the one wrinkle in this is that the transformation for model B needs the transformed data from A. So it's going to say, and that should be DFA and not DF model A. And so that's really the only thing that's going on here that's special or interesting at all, is that your second transformation wants your first transformation's data to work with. But this is a standard prototyping, approach, right? If you do it with object-oriented, you have these same functions, but now you have this class that I've created called data. And essentially what happens is this data class, when you instantiate it, when you create an instance of it, you need to give it raw data, and it will automatically and immediately call the clean function. It also has these other attributes, which are the data frame with the A shape and the data frame with the B shape, which currently don't have anything. And then what it will say is that if you want to get this data frame A, you have to call this method getDFA. And the reason why this is handy is because it will check, did I already calculate DFA? Does that already exist? If I didn't, then call this model transform function and make my data nice. That's not a big deal here with DFA, but with DFB, where it has essentially a dependency, it needs to already have DFA calculated, this is really handy because it'll check, if we don't already have this data, call the transformation, and it already knows you need to call for DFA. So because it uses the getDFA method, it again checks, do we have DFA? If not, make it. And so it does all this thinking for you about whether or not your dependencies are in place and takes care of them right away. And then you call your model methods, and they work really nicely. So here, the code that is the same as the code here is just this. Load the data, declare the instance of the data class, and then call the model methods. And all the data management, the data shaping, the managing, keeping and making sure that you have the right forms of data in the right place, that all gets managed by the class. You don't have to have that in your brain. Now, you may be looking at this and going, okay, Bethany, you wrote all this code to not have to have 2 lines in your procedural. This is not, this is very silly. But here is what using an object-oriented approach prevents. Yes, these are the different sections and how they correspond. So here is what, if we tuck away all the functions and all the classes, these are the things that compare. But here's what happens if you change the code a little bit. So relative to this code, the only thing I've done is I've said I'm not interested in model B anymore. I'm not interested in model A anymore. I only want to fit model B. My life has changed. I just don't care about model A at this moment. So I change the code. I drop, the making of model A's data, and I drop the model A call because I don't need it anymore. And so this is the modified code for, and this should say procedural over here and OOP over there. This is what happens when you're making slides at midnight. And so if I then, I've gotten rid of the stuff I don't care about, everything to do with model A, I call my code, this is going to crash, and this is going to run. Why is that? Well, it's because of the dependency that I mentioned, where when you're fitting model B, it assumes that you have model A, that data already there. It assumes that you've already created an intermediary form of data called DFA, right? And so here, what you need to do to make it run is essentially remember for yourself, oh wait, model B doesn't just take DF clean, it takes DFA. So I need to run the DFA transformer on that as well. And that's, in a way, that's trivial, right? With this simple code like this, it's very easy for you to go in and go, oh, duh, I forgot that, whatever. But as your code gets more complex, as you have more methods, as you have more moving parts, having to remember all that yourself gets more and more difficult, right? You are going to forget things. And if you're working in a team, how does the rest of the team know what you remember about structure? And they can figure it out for themselves by having the code crash and debugging it all the time. Or you can just prevent the whole thing by having code that, with the classes, where that dependency is already encoded right here. So instead of you having to think, you told the program how these dependencies relate. The program can track what state your data is in, and you don't have to worry about it anymore. And so that's sort of what I'm, really advocating about, is that this is important and nice. That when you use object-oriented programming for production, you can write, your code base is easier to maintain, you have nice objects, it's all great. And I'm really annoyed now because I have a GitHub with a slightly better worked out code example that I wanted to link to and apparently did not. So I don't know what you can see. I'm not going to work through the example, but if you go to Bethany Cookie to you, PyCon, I've got some examples of this sort of code to play with. And now I just want to talk a little bit about how this happened to me. So I work at Empower the User. We are a corporate e-learning company, and I was their only data scientist when they hired me. And so I had to build an entire data infrastructure from scratch, including a process for creating some rather elaborate data reports. And I did everything the way that the examples online told me to. Because I'd been working at this for a while, but still, the way you learn initially is what shapes what you do. And so I ended up having this thing with, I think, 5 different forms of the same data frame and 7 different functions, all of which called different combinations of those. And I was constantly going, all right, I need to have data 2 here, and then when I pass this function, now data 2 has a slightly different shape. And I was giving myself absolutely headaches. And then I thought, well, it's just because my code is messy. I'll refactor it and it'll be fine. Well, I refactored it, it was still not fine. And so that was when I started using objects. And I'd been hesitant at first because when we're trained about objects, we're usually trained to think of them as essentially a collection of variables that have things in them like, shape, color, weight, one tiny little int or float or string. It's a collection of those things. And what I was using instead, I had a collection of data frames, right? And so that wasn't intuitive, it's not the canonical example. It wasn't a bunch of things that described an object. It was a bunch of different forms of my data. So it wasn't, here's my data and here's some things that describe it. It was, here's my data, and then this is my data when it's transformed like that, and this is my data when it's transformed like that. Now, there are situations where you don't want to use this approach, right? It is quite memory intensive, right? Because I've essentially got multiple copies of my data existing at the same time. In my case, the priority was to have the code run fast. We had lots of memory, but not as much processing power. And so being able to store different versions of the data, because I knew I would need them more than once, was really, really important. And so this approach worked really well for me. If you're in a situation where you have lots of processing power but not much memory, then you really don't want to do this because it would be hugely, hugely inefficient for you, and you'd have lots of problems because you'd have all this data cluttering things up when you could in fact be calculating it anew every time. And so I'm not saying in any way, and I hope no one thinks this, that you should always use object-oriented programming for production. I certainly don't think you should use it for your prototyping unless you really, really love it. But what I am saying is that if you find yourself constantly having to use your own memory when you're working with your own code, if you're constantly having to go, oh yeah, I need to remember to change that thing up there because I changed the thing down there, that might be a sign that you want to try out an object-oriented approach for your stuff later. So thank you, everybody, very much.